Lab 23, LeChatelier's principle. LeChatelier's principle, also known as Chatelier's principle or the equilibrium law, states that when a system experiences a disturbance, such as concentration, temperature, or pressure changes, it will respond to restore a new equilibrium state. For example, if more reactants are added to a system, LeChatelier's principle predicts that the reaction will generate more products to offset the change and restore equilibrium. This chart lists some of the possible stresses and their effects on a given system. Lab 23. As per our lab manual, concepts. As you learned in your text, many reactions and processes are reversible. That is, a forward reaction forms products at the same time that a reverse reaction reforms reactants. The forward reaction has its greatest rate at the beginning, and then it gradually slows down as the reactants are being consumed. On the other hand, the reverse reaction is extremely slow at the beginning, but as the concentration of the products increases, it becomes faster and faster. Eventually, the rate of the forward reaction equals the rate of the reverse reaction, and equilibrium is established. Since both reactions are now proceeding at the same rate, the concentration of each type of ion or molecule remains constant. There are three important stresses that affect an equilibrium: change in concentration, change in pressure for gases only, and change in temperature. According to LeChatelier's principle, equilibrium will shift to relieve the effect of any stress. In this experiment, you will demonstrate LeChatelier's principle as it applies to a dissolution process by changing the concentration of ions in a saturated sodium chloride solution. Adding sodium chloride to water causes the salt to dissociate into sodium and chloride ions. Initially, the rate of the forward process, dissolution, increases as the salt dissolves. As the system approaches equilibrium, the rate of the forward process decreases, and the rate of the reverse process, precipitation, increases. When the system reaches equilibrium, both processes are occurring at the same time. The evidence of this fact is that no more sodium chloride dissolves in the water at this temperature. If the equilibrium is now stressed by increasing the concentration of one of the products, the reaction will be shifted to the left. A white precipitate, sodium chloride, will appear, and a new equilibrium will be established. In class, our lab procedure will involve beakers, filter paper, goggles, laboratory apron, pipettes, test tubes, hydrochloric acid, sodium chloride, and water. We will prepare and filter a saturated sodium chloride solution, and we will add hydrochloric acid to it and observe the results. Next, we will add distilled water to the solution and observe the results. If performing this in a lab, what would you see? You'd see something like this.
Alright, so welcome to this demonstration where we're going to look at LeChatelier's principle, the idea that I can shift equilibrium from one side, from a reactant side to a product side or back again by manipulating my reaction conditions. So the physical process that we're looking at right now is a saturated solution of sodium chloride. What that means is that the solution cannot hold any more sodium chloride than it already has. It is at equilibrium. And I'm going to disturb that equilibrium by adding HCl. And if you pay attention to the chemical formulas, of course, you know that HCl and NaCl have an ion in common. So that ought to affect the equilibrium. You hopefully should have a prediction about in which way. I'm just going to add a few drops of very concentrated HCl to my solution. And I'm going to give it a stir. I'm going to add just a tiny bit more. And I'm afraid that you aren't going to be able to see this on this camera, but I can tell you from where I sit that the sodium chloride solution is cloudier than it was. And that's because adding the HCl has forced some of the sodium chloride back into its solid form, and that solid is what gives it its cloudy appearance. So demonstration 1, I took concentrated hydrochloric acid, added it to a sodium chloride solution that already had all the sodium chloride it could hold, and I pushed some sodium chloride back out. I made my solution cloudy.
Or this. And this occurs because of something called the common ion effect.
The common ion effect can be tricky for Gen Chem students, probably because it's named after what it is. Basically, the common ion effect says if you have an ion in common, it decreases solubility. Here I have a saturated NaCl solution. I'm going to add some concentrated HCl to that. So what's the ion in common? The white stuff you see is solid NaCl coming out. Now I'm going to add a large amount of concentrated HCl. That white precipitate is solid NaCl crashing out of solution.
And here our friend Professor Dave, with a haircut, explains the common ion
effect.
effect.
Dave, let's learn about the common ion effect.
He knows a lot about the science stuff. Professor Dave explains.
As we continue to learn about solubility and precipitates, we are beginning to understand ways that we can predict or even control precipitation. One such approach we must understand involves something called the common ion effect. So let's learn precisely what this means. The common ion effect is an application of LeChatelier's principle, which we learned all about in an earlier tutorial. So if you need to review, check that out now. Otherwise, we know that under this principle, which describes the behavior of equilibria, if we were to add an additional amount of one of the components in an equilibrium, the equilibrium would shift towards the other side, using up some of that additional component and creating more of the substances on the other side. Let's now look at an equilibrium between, say, silver iodide and the aqueous silver and iodide ions. If we are interested in forming a silver iodide precipitate, one way we can do this is to add some potassium iodide. Potassium iodide shares a common ion with silver iodide, that being the iodide ion. If there is more iodide ion in solution, that will affect the equilibrium and it will shift left to use up the excess iodide ions. If the equilibrium shifts left, that means more silver iodide precipitate will form. So this is a method of promoting precipitation.
And at this point, our awesome friend, Professor Dave, gets into a lot of mathy stuff that we don't need for this particular lab. So looking back at Lab 23, Define equilibrium. Chemical equilibrium, a condition in the course of a reversible chemical reaction in which no net change in the amounts of reactants or products occurs. What happens to the concentration of ions when the solution is at equilibrium? In a chemical equilibrium, the forward and reverse reactions occur at equal rates, and the concentration of products and reactants remain constant. What stresses will affect equilibrium? 3 types of stresses can alter the composition of an equilibrium system: adding or removing reactants or products, changing the total pressure or volume, and changing the temperature of the system. What is LeChatelier's principle? LeChatelier's principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of the equilibrium shifts to counteract the change to reestablish an equilibrium. If a chemical reaction is at equilibrium and experiences a change in pressure, temperature, or concentration of products or reactants, the equilibrium shifts in the opposite direction to offset the change. Explain the phrase equilibrium is shifted forward. It means that equilibrium will shift to the right towards the side of the products. The rate of forward reaction exceeds the rate of reverse reaction. And after performing the experiment and gathering your data, you are asked, what substance was formed as the hydrochloric acid was added to the saturated solution, and why? When concentrated hydrochloric acid is added to the test tube containing saturated sodium chloride solution, white sodium chloride precipitates out due to the common ion effect. The common ion effect is a phenomenon in which the addition of an ion common to 2 solutes causes precipitation or reduces ionization. What happens if you add water to the test tube? The addition of water to the system will dilute all of the aqueous species, thus reducing their concentration. Since there is a greater change of aqueous species on the left compared to the right, the reaction will shift to the left-hand side. What do you think would happen if trisodium phosphate was added instead of hydrochloric acid? The equation is below, and you would get solid precipitate. If this exercise had been performed in a pressure chamber at 2 atmospheres, would the result be different? If you increase the pressure of a gas, you squeeze it into a smaller volume. In order for a reaction to happen, the particles must first collide. The volume of solids or liquids does not change with pressure. Increasing the pressure on solids and liquids has no effect on the reaction rate. Now complete your lab report using this data.